Welcome all. Today we'll be discussing about the evolution of operating system. So under that, the first and the foremost thing that we need to discuss is batch processing system or systems. So in this, you'll be having n number of batch consisting of n number of processes running. So let me assume that P1, P2 and P3 are similar jobs or tasks, and this we call it as batch 1. Similarly, you'll be having batch 2, so in which you'll be having P4, P5 and P6. Similarly, you'll be having batch 3, so it consists of P7, P8 and P9. So all these things are nothing but each and every batch does consist of similar tasks or similar jobs, and the processor, what it does is, so it takes this batch and assigns it to the CPU, and the CPU processes P1, P2 and P3 and gives the output to the users. It gives it to the users. And here one important thing that you need to understand is, when the processor has finished P1, the output is not given to the user. The output will be given to the user only all this processor P1, P2 and P3 all are complete as a batch. Then only the users would be getting the output. Now let us try to understand the merits. The merits is the CPU processor time is utilized, or utilization is to the maximum. The next thing is maximum resource utilization, and it is suited for large CPU processing jobs. So these are the merits of batch processing system. Now let us come to the demerits. The demerits are throughput is very less, and for interactive input output programs, this method is not suited. So the next topic that we have to discuss is multi-programming and the evolution of operating system. So under this, the system allows multiple programs, reside in separate areas of the core at the same time. So the next topic is fragmentation. So fragmentation, here it's a problem actually. So the problem is holes or unused portions of core is called fragmentation. And here you do have two different kinds of problems. The first one is internal fragmentation, and the second one is called as the external fragmentation. So the next concept that we need to discuss under evolution of operating system is relocatable partitioned core. Here, this particular mechanism allows the unused portions to be condensed into one contiguous or one continuous part of the core. So this is the concept that we need to remember in relocatable partition core. The next concept that we need to discuss is paging. In paging, it's a method of memory allocation. So wherein which the memory is subdivided into equal portions, or we call it as pages, and the core is divided into equal portions or blocks. The pages are loaded into the blocks. So here there are two paging techniques. So the first one is simple paging, and the second one is demand paging. So in simple paging, all the pages of the programs must be in core for the execution. In demand paging, what we see is a program can be executed without all pages in core. So that is, pages are fetched into the core as they are needed. So the next concept is timing under evolution of operating system. This is a method where allocating of processor time is done. Typically characterized by interacting processing. So here we employ what is called as time slicing or time sharing of the CPU, which allow quick response to each user. The next concept that we need to discuss under evolution of operating system is virtual memory. This virtual memory consists of namespace, address space. So this consists of addresses that may be generated by a processor during execution. Of a computation. And one more point that you have to understand is the memory space consists of set of addresses which corresponds to physical memory location. The next topic that we need to discuss under evolution of operating system is segmentation. Here it provides a large namespace and it is a good protection mechanism. And this protection and sharing allows controlled access to segments. So these are the things that you have to discuss if anything is asked based on evolution of operating system. Thank you.